Okay, in this video, we will see the techniques of integration, what we call integration by partial fractions. We will do these two examples, but first let's see the partial fraction mean for different types of structures. In the table, you can observe that form of rational functions and the partial fraction decomposition. For instance, whenever you have a rational function of the form at the denominator, whenever it is factorized, x minus a times x minus b, two linear factors only. So the corresponding partial fraction decomposition will be constant. For each linear, you will take at the numerator a constant, a over x minus a plus b over x minus b. But if the linear factor has multiplicity, for instance, in the second row, x minus a square. So you will take constant a over the factor x minus a plus constant b over the factor square. If the multiplicity is 3, you will continue plus c over x minus a cubed and so on. If all are linear, always you take only once each factor, a over x minus a plus b over x minus b plus c over x minus c. Look, whenever you have linear factor, two linear factor and one has multiplicity 2, you will use the same thing what we have seen here, x minus a square. So for x minus a, you will have a over x minus a plus b over x minus a square for multiplicity 2, plus for the other factor, c over x minus b. If x minus b has multiplicity, you proceed in the same manner. If you have, and instead of linear factor, if you have quadratic factor, non-decomposable quadratic function, x squared plus bx plus c, if we can't decompose into linear factors, we will take for linear factor, we will have constant over x minus a. For quadratic factor, we will take linear here, bx plus c over the quadratic factor. So you can proceed on this format for any multiplicity. Now let's see using the above example. The first example here, we have this rational function 4x plus over x squared plus x minus 6. Solution. Look, 4x plus 2 over x squared plus x minus 6. We need to factorize the denominator, 4x plus 2 over x squared plus x minus 6, the product negative 6, the sum positive 1, 3 times negative 2. Therefore, our linear factor will be x minus 2, x plus 3. So we need to represent based on the above. Look, remember here, whenever you have two linear, x minus a, x minus b, you will take a over x minus a, b over x minus b. Therefore, here we assume we let it to be for this a over the first linear factor, x minus 2, plus the other constant b over the other linear factor, x plus 3. Then this is the sum of rational expression. So apply addition of rational expression. When you add, you will get the common denominator will be x minus 2 times x plus 3 and crisscross a times x plus 3, ax plus 3a plus b times x minus 2, bx minus 2b. So these two are equal and they have the same denominator. So from that, we know the numerator should be equal. Therefore, 4x plus 2 is equal to ax plus bx, a plus bx, plus the constant term 3a minus 2b, 3a minus 2b. Now equality of two polynomials. Whenever we have two polynomials equal, for every real number, the corresponding coefficients are equal. If for every real number they are equal, means for x is equal to 0, they are equal. When x is 0, you'll have the constant only. B is equal to, 2 is equal to 3a minus 2b. Therefore, we have 3a minus 2b is equal to 2. So they are equal, they cancel out. For x1, we will have a plus b is equal to 4. So simply you can say that whenever you have two polynomials equal, corresponding coefficients are equal. The coefficient of the term is the same degree, the same power will be equal. So from that we have two linear equations. We have two linear equations with two unknown. Let's solve simultaneously or by substitution, but it's better. Let's multiply the lower one by 2. So this will give us 3a minus 2b is equal to 2, and 2a plus 2b is equal to 2 times 4, that's 8. Then add downward. 3a plus 2a, 5a, minus 2b plus 2b, 0 is equal to 2 plus 8, that is 10. Divide both sides by 5 is equal to 2. Then what is b? From the second equation, we know that b is equal to 4 minus a. A is 2, therefore b is equal to 2. Now, look, the integral of 4x plus 2 over x squared plus x minus 6 dx is equal to the integral of, look, this expression means a over x minus 2 plus b over x plus 3. A is 2, this is 2, this is 2. Therefore, we can substitute 2 over x minus 2 plus b 2 over x plus 3 dx. So this is the integral of 2 times the integral of 1 over x minus 2 dx from integration property, 2 times the integral of 1 over x plus 3 dx. So you can find the integral of 1 over x minus 2 by using integration by substitution. Therefore, the result will 2 times ln of absolute value of x minus 2 plus 2 times absolute value of the ln of absolute value of x plus 3 plus the constant c. Let's come to the second example. Okay, in this example, we are going to evaluate the indefinite integral of the rational function 1 over x times x squared plus 1, one linear and one quadratic with multiplicity 1, 1. Now let's see. Solution 1 over x times x squared plus 1. X squared plus 1, no more decomposition. So we have to assume, we have to let 1 over x times x squared plus 1 as a over the linear factor x plus, for the quadratic, we have to take linear at the numerator, bx plus c over x squared plus 1. Then from addition, we know that crisscross and take the denominator, the product of the two denominators, x times x squared plus 1, crisscross ax squared plus a plus bx squared plus cx. So these two rational functions are equal and having the same denominator. That implies the numerator 1 is equal to x squared plus bx squared, a plus b common factor x squared plus cx plus the constant a. Then these two are equal for every real number, means a plus b on the right side, the coefficient of x squared. On the left side, the coefficient of x squared 0. Cx, the coefficient of x, c, is equal to no coefficient here, c is 0. And the constant term is a is constant term, here we have 1. Therefore, this implies b is equal to minus of a, that's negative 1. Therefore, we have here 1 over x times x squared plus 1 is equal to a is 1. 1 over x plus b is minus 1 minus x plus what is c? 0 over x squared plus 1. You see, 1 over x minus, that is 1 over x minus x over x squared plus 1. X squared plus 1. So, the integral of 1 over x times x squared plus 1 dx is equal to the integral of this function is equal with 1 over x minus x over x squared plus 1, that is okay dx. Then from integration property we know that the integral of 1 over x dx minus the integral of x over x squared plus 1 dx. Simply you have to remember what's the integral of ln x. It is basic function, that is ln of absolute value of x minus what's the integral of x over x squared plus 1 dx. We have to find this integral. So we use here integration by substitution. So let's consider here. Let's u is equal to x squared plus 1. Then du by dx is equal to 2x. So crisscross and you'll obtain from this 1 over 2 du is equal to x dx. So x dx 1 over 2 du. Therefore, this integral will be the integral of 1 over 2 x squared plus 1 u du, x dx 1 over 2 du, and x squared plus 1 is u, 1 over 2 u du. This is equal to ln of absolute value of x minus the integral of 1 over u du, that's 1 over 2 ln of absolute value of u plus c, 1 over u, the integral of 1 over u. Therefore, this is equal to ln of absolute value of x minus 1 over 2 ln of absolute value of u, x squared plus 1 plus the constant c. This is the answer. In the next video, I will do some problems on using reduction formula and some trigonometric identities.